Hi everyone, we are from Group 17. I am Yap Chang Lo. Next is Wong Chiu Hee, Wong Yemi, Chelvi Diana, and Muhammad Fakhruddin. So now we go to our topic.
Hello, my name is Chelvidiana. I'm from Group 17. Today I will be explaining about how client and web server communicate. Client. A client can be machine or a program, which the machine include computer, tablet, mobile phones, etc. A client program is a program that allows the user to make requests. Server. A server is a computer program that is obviously not a device. Server provide functionality and serve other programs called clients. A single server can serve multiple clients at the same time. A server can contain web resources, host web applications, and stores user and program data, etc. A server always listening for a request, and as soon as it receives one, it responds with a message. For client and server communication, in general, a service is an abstraction of computer resources, and a client does not have to be concerned with how the server performs while fulfilling the request and delivering the response. The client only has to understand the response based on the well-known application protocol. In example, the content and the formatting of the data for the requested service. Clients and servers exchange message in a request-response messaging term. The client sends requests and the server returns a response. This exchange of messages is an example of inter-process communication. To communicate, the computer must have a common language and they must follow rules so that both the client and the server know what to expect. To formalize the data exchange even further, the server may implement an application programming interface, which is the API. The API is an abstraction layer for accessing a service. By restricting communication to a specific content format, it facilitates parsing. By abstracting access, it facilitates cross-platform data exchange. For example, in client and server communication, when a bank customer accesses online banking service with a web browser, which is the client, and then the client initiates a request to the bank's web server. The customer's login credential may be stored in a database, and the web server accesses the database server as a client. An application server interprets the returned data by applying the bank business logic and provides the output to the web server. Finally, the web server returns the result to the client web browser for display. This is the client-server model. We can see that the arrow that going through the web server, it shows that it the client is requesting something from the server, and the arrow that pointing towards the laptop means that the server is giving response to the client. And that's all from me. Thank you.
Hi, I am Monsu here. I am going to present about why all UTP cables are twisted together. What is UTP? UTP is unshielded twisted pair. The picture below here shows the UTP cables. What is UTP? UTP is a ubiquitous type of copper cable. It consists of 4 pairs of wire medium, and then each of the 8 individual copper wires in the UTP cable is covered by the insulating material. And UTP is most commonly used in telephone wiring and local area networks. And there are 2 individual wires in a single pair that are twisted around each other together. And then the picture here shows the unshielded twisted pair cable, and there is a outer jacket that will protect the copper wire from physical damage. And then there is also twisted pair cable which protect the signal from the interference. And then the color coded plastic insulation cables is electrically isolate wires from each other, and then it will identify each pair. Next is about the process. First, a pair of wires form a circuit that can transmit data, and then the pairs are twisted to provide protection against a crosstalk. A crosstalk means the noise that generated by the adjacent pair of the wires, and then when electrical current flow to a wires, it will create a small circular magnetic field around the wires. When 2 wires in an electrical circuit are pressed closely together, their magnetic fields are the exact opposite of each other. Therefore, the two magnetic fields cancel each other out. They also cancel out any outside magnetic fields. Therefore, twisting the wires can enhance the cancellation effect. By using this cancellation together with twisting the wires, the cable designer can effectively provide self-shielding for wires paired within the network media. Okay, um, therefore, UTP cables are all twisted because they can reduce the crosstalk. Like crosstalk is the noise generated by the adjacent pair, and then beside that, UTP cables also provide back resistance toward the electromagnetic interference. It also can degrade network performance, and then each signal on a twisted pair requires both wires. So twisted pair wires are color coded to make it easy to identify each pair. So every UTP cables are usually many color such as red, orange, green, yellow. Okay, so the advantage of using UTP cables are UTP cables are smaller and easier to install in bulk or narrow space or area. And besides that, it also do not require the grounding cable during the installation as it does not have any extra metal conductor or covering. Besides that, using the UTP cables also cheaper, and it do not rely on outer shell, and it can transmit data as fast as possible. So as a conclusion, UTP cable is most commonly being used by the industry nowadays, such as telecom Malaysia, right? Because mm, since UTP cable are usually used in the telephone wire nowadays, and local area network, as it is more cheaper than other type of the wire like STP. So each function is also make it very available to be used in the industry nowadays. So that's all for my part. Thank you.
Uh, Good evening, everyone. My name is Muhammad Fakhruddin bin Ismail. My metric number is BI15110354. My task is to explain how email system work based on these two protocols, which are SMTP protocol and POP3. So to understand how email system work, I will explain the component of email. To send, they require email client, email server, and POP protocol. POP3. POP3 mean by this a version of protocol. The email client, which we using today, such as Gmail, basically they provide a basic function like compose message, delete message, and attach some attachment like picture or video, and so on. Every email client have their own unique tools and as advanced features. So we move to email server. Email server, when we try to send email, it will direct go to there. It's like to simplify this, email server are actually sending mail to the recipient. Meaning to say, every time we send our email to people like our friend, it will connect to this mail server and then will go to the recipients. For the POP3 protocol, post office protocol server, it is actually doing the job by receive the email from the sender. So let me explain how the email work based on this protocol. I will explain briefly. My other friend will try to explain the difference between these two protocols, the POP3 and SMTP. So let's get started. When we try to send email to other people like our friend, the email client will connect to the email server. The email server is, like I mentioned before, centralized computer by handle email. How can they handle email? By responsible for sending email to the recipient. This is called SMTP, Simple Mail Transfer Protocol Server. One SMTP server can transfer and connect to another SMTP server to desired location by hop. That's called hopping. Every email has their own unique ID, right? Just in case, my ID is mofavis@gmail.com. So my email client I'm using is Google. When email sent, the email client will connect to this SMTP server of the recipient mail. The email client will transmit of the sender address, recipient address, and our message. SMTP server will try to locating where about the recipient email address. By using the email ID, it will locate the domain name. Domain name is, in case my email, gmail.com. This domain name provide a unique web address called as Internet Protocol. SMTP server then proceed to transfer email to recipient SMTP mail server. So From there, the POP3 or post office protocol server will receive this email by doing the job I mentioned earlier. The POP3 basically receive email from sender. This POP3 server will then hand over message to the recipients till the recipient log in and check in inbox and download it. There is one other protocol but not required to explain in our assignment, which is IMAP. That's all from me. Thank you.
My name is Wang Yanmi from Group 17. I will present about the differences between the SMTP and POP3 protocols. So first, SMTP stands for Simple Mail Transfer Protocol, and POP stands for Post Office Protocol. POP3 is the latest version, and SMTP is a message transfer agent, while the POP3 is the message access agent. So SMTP is a transmission control protocol, TCP, and POP3 it belongs to application layer of the protocols in TCP IP suite. SMTP transfers the message from client computers to the recipient mail server, or it is a push protocol and is used to send the mail. While POP3 is pull the message from the mailbox present on the mail server and at recipient side to the recipient's computer. It means that it's used to retrieve those mails at the receiver's side. So SMTP it implies two times. So the first is between the sender and sender mail server, and second is the between sender mail server and receiver mail server. So the POP3 it implies between the receiver and receiver mail server. So these are all the key differences of SMTP and POP3. Thank you.
Hi everyone, I am Yap Shangla. Today I will show you how the NRZL and the NRZI work and the difference in their concept. Before that, I will tell you what is NRZ. NRZ stands for non-return to zero, refer to a form of digital data transmission in which the binary low and high state represented by numerals 0 and 1 are transmitted by specific and constant direct current voltage. NRZL stands for non-return to zero level. Its signal changes when the binary change from 0 to 1 or 1 to 0. Now I will show you how it works. So now, first I let the 0 as the negative signal. So when 0 to 1, it will change the signal. So negative will to positive. So 1 to 0 change from the positive to negative. Now it's 0 to 1, change from negative to positive. 1 to 0, change again. 0 to 1, change again. Now it's 1 to 1. 1 to 1, no change, so continue. 1 to 0, change to negative. 0 to 0, continue. 0 to 1, change. Remember that when the binary change from 0 to 1 or 1 to 0, the signal will be changed. So mean that from beginning and 0 negative, when it from 0 to 1, it will change the signal to positive. And 1 to 0, change again. 0 to 1, change again. 1 to 0, change to negative, 0 to 1 change, 1 to 1 no change, 1 to 0 change, 0 to 0 no change, 0 to 1 change. So mean that the data represent by the signal level. So 1 positive, 1 positive, 1 positive, 1 positive, 1 positive, 0 as the negative, 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 negative. So the next is the NRZI, non-return to zero inverter. Work by using the inversion of voltage level to represent the binary 1. Signal change when the next bit is 1. No signal change when the next bit is 0. So first, let the 0 as the negative signal. So 0 to 1. The next bit is 1. So the signal will be changed to positive. The next bit is 0. Here say no signal change when next bit is 0. So it will continue, no change. 1 change again. 0 continue. 1 change again. 1 now is next is the 1, so change again. 0 no change. 0 no change. 1 change. So you can see that from 0 the next bit is 1, it will change. Next bit is 0, continue. Next bit is 1, change. Next bit is 0, continue. Next bit 1, change. Next bit 1, change. Next bit 0, continue. Next bit 0, continue. Next bit 1, change. So this is how the NRZI work. So this is the graph. So what is the difference between the NRZL and NRZI in the concept? So in NRZL, two different voltage for the 0 and 1, negative voltage for one value and positive for the another one, like the example, binary 0 as the negative signal, binary 1 as the positive signal. But in NRZI, maintain a constant voltage pulse for the duration of a bit time. Signal will change when the next bit is 1. No signal change when next bit is 0. Only change the signal when the next bit is 1. 0, nothing changes. So the next is similarity. They are simple and low frequency response but has the direct current component. They are lack of synchronization. This is not good for the transmission. So that's all for today. Thank you.